Hi everyone, welcome back. Today let's study about heights and distances. This chapter is the continuation of trigonometry, and by using the application of trigonometry we can find the heights and distances of objects. For that, first let's understand the two keywords, that is the angle of elevation and the angle of depression. Just consider AB be a tower standing on a level ground, and a man standing at a point C is observing an object which is at a point A here. AB is a tower standing on a level ground, and a man at a point C is observing an object at A. And the line CA is the line of sight. Line of sight. And the angle between this is horizontal because it is standing on a level ground, and the angle between the line of sight and the horizontal is called the angle of elevation. Angle of elevation. So this is the angle of elevation, the angle between the horizontal and the line of sight. That is the angle of elevation. We can represent it by using theta. Similarly, if a man standing at a point A, this is the point A, and observing an object at C, then if you draw a horizontal here, this is the horizontal. Then the angle between the horizontal and the line of sight, and this is the line of sight. This is called as the angle of depression. Angle of depression. Angle of depression. So if a man standing at a point A and viewing an object at C, then the angle between the line of sight AC and the horizontal, we can draw a horizontal over here, and the angle between the line of sight and the horizontal is called as the angle of depression. And here, if a man is standing at the point C and viewing the object at A, then the angle between the horizontal and the line of sight is called as angle of elevation. If any object which is at a height, if you are observing, that becomes the angle of elevation, and from a height, if you are looking down, then the angle becomes the angle of depression. Now here these two lines are parallel, therefore we can say that this angle of depression what we get here is same as the angle here, since when two lines are parallel, alternate angles formed are equal. While solving the sums, we can use this property and solve it. Now let's solve few sums on this. Look at the first question. The height of a tree is √3 times the length of its shadow. Find the angle of elevation of the sun. Here we can use the trigonometrical ratios and find our answer. It is given that the height of the tree is √3 times the length of its shadow. Imagine this is the tree and here is the shadow of the tree. It's given that the length of the tree is √3 times its shadow. Consider x is the length of the shadow. Then the height of the tree is √3x. If you join this line, find the angle of elevation of the sun. We have to find the angle of elevation. Let it be ABC. And here this becomes the angle of elevation theta. Now by considering these two values, we have to form a trigonometrical ratio and find the angle of elevation. Here if you consider theta, this is the opposite side and this is the adjacent side. So the trigonometrical ratio which is connected with these two is tan theta. So we can write, let x be the length of the shadow. Therefore, the height of the tree is a √3x. That is by the given condition. Now, by considering these two sides, we can write the trigonometrical ratio as tan theta. Tan theta is equal to opposite side by adjacent side, that is AB by BC. Now, tan theta is equal to the AB is root 3x by BC is x. When you cancel these two, you'll get tan theta is equal to root 3. Tan theta is root 3. We need to see for what value of theta, tan theta is root 3. We can find from the tables tan theta is equal to tan 60. This implies theta is equal to 60 degree. Therefore, the angle of elevation of the sun is 60 degree. Angle of elevation is 60 degree. Look at the next question. A kite is attached to a string. Find the length of the string when the height of the kite is 60 meters and the string makes an angle 30 degree with the ground. First, let's draw the diagram. Here, this is the string of the kite. A, B, C. Let's write it. So, AC is the string here and the height of the kite is 60 meters. It's given that the kite is at a height of 60 meters from the ground. This BC is the ground and this is the height of the kite and this AC is the kite. Now, the question is, when the string makes an angle 30 degree with the ground, we need to find the length of the string. So here, this is the string and this is making an angle of 30 degree with the ground. We have to find the length of this string, that is AC value we have to find. So let's write, let x be the length of the string. Let this be x. Now here we have the angle of elevation, or there is an angle and there are two sides with the datas. We need to find a trigonometrical ratio which connects these two. This is the angle of reference and this is the opposite side and this is the hypotenuse. So opposite side by hypotenuse is sine theta. Now let's write sine theta is equal to AB by AC. Here theta is 30 degree. Sine 30 is equal to AB is 60 meters by AC is x. Now the value of sine theta is 1 by 2. 1 by 2 is equal to 60 by x. Since sine 30 is equal to 1 by 2. Now by cross multiply, x is equal to 60 into 2, that's equal to 120 meters. Therefore, the length of the string is 120 meters. Look at the next question. A boy 1.6 meter tall is 20 meter away from the tower and observes an angle of elevation of the top of the tower to be 45 degree. There are two cases given here. The first case it is 45 degree and the second case it is 60 degree. Find the height of the tower in each case. So first let's draw the diagram. Here it is given that the boy is standing 20 meters away from the tower. So let this be the tower and this is the distance of the boy from the tower, that is 20 meters. And he observes an angle of elevation of the top of the tower to be 45 degree. And one more data is given that his height is 1.6 meters. So this is the height of the boy, that is 1.6 meters. And from this point he is observing the angle of elevation, and that is, in the first case it is 45 degree and in the second case it is 60 degree. Now here this is not a right angle triangle. So what we have to do is we have to draw a line, a parallel line to the base. And here if we join, this becomes a right angle triangle and we can apply the trigonometrical ratio and find the height of the tower. So since this is 20 meters, even this will be 20 meters since it is parallel and the distances are equal. This also will be 1.6 meters. Now in the first case the angle of elevation is 45 degree. This is 45 degree. That is the line of sight and the horizontal. the angle between the line of sight and the horizontal is 45 degree. Now let's consider this height is x and the height of the tower is x plus 1.6 meters. Mark this as A, B, C, D and E. Let's start doing it. Let AE be x. So the length AE is x. When we find the length of the tower, we can say that is x plus 1.6 meters. Now consider this triangle AED. Consider triangle AED. If you consider triangle AED, this is 45 degree, this is the opposite side and this is the adjacent side. Opposite side by adjacent side is tan theta. Now, tan theta is equal to opposite side is AE by adjacent side is ED. So, here theta is 45 degree, tan 45 is equal to AE is x and ED is 20. Tan 45 is 1 is equal to x by 20. On cross multiplication, we will get the value of x as, this implies x is equal to 20 meters. So we got the part that is AE is 20 meters. When the angle of elevation is 45 degree, that's the first part of the question. Here we got the length AE as 20 meters. Therefore, the length of the tower is equal to 20 plus 1.6, that's equal to 21.6 meters. So in this case, we are getting the length of the tower is 21.6 meters. That's the first part of the question. Now in the second part, when the angle of elevation is 60 degree, what happens to the height of the tower? So this we can change as 60. This becomes 60 degree. Remaining all the steps are how we have completed in the first part. The same way, let's write tan theta is equal to AE by ED. That is tan 60. Tan 60 is equal to AE is x by 20. Tan 60 is root 3. Root 3 is equal to x by 20. This implies x is equal to 20 root 3. That is equal to 20 into 1.732. Since the value of root 3 is 1.732 or tan 60 is 1.732. When we multiply 20 into 1.732, we will get this as 34.64. Now, when we are finding the height of the tower, as we know, we have to add 1.6 also to this value to get the height of the tower. Therefore, the height of the tower is equal to 34.64 plus 1.6 and that is equal to 36.24 meters. Therefore, the height of the tower when the angle of elevation is 60 degree is 36.24 meters. Now this question is for you. Solve it and let me know the answer. The angle of elevation of the top of the tower from a point on the ground and at a distance of 160 meters from its foot is found to be 60 degree. Find the height of the tower. That's all for today. We'll meet in the next class with the continuation topic of the same. Thank you.